Hello friend, this is Bit Electronic System. Let's we discuss on one more interesting and important part of embedded system is serial communication protocols. Before starting with serial or parallel communication protocols, let's break the terminology in three parts. The communication is very well known terminology, which involves the exchange of information between two or more mediums. Well, in embedded systems, the communication means the exchange of data between two microcontrollers in the form of bits. Now, this exchange of data bits in microcontroller is done by some set of defined rules known as communication protocols. And if the data is sent in series or parallel, then the communication protocol is known as serial or parallel communication protocol. Communication is done as shown in block diagram and examples of serial communication protocols such as CAN, Ethernet, I2C, SPI, RS-232, USB, one wire and SATA etc. Communication is done as shown in examples of parallel communication protocols are ISA, ATA, SCSI, PCIN, IAA 488. There are different types of data transfer available in the digital electronics, such as serial communication and parallel communication. Now, let's we discuss serial communication in details. In serial communication, data is sent in the form of bits, that is, binary pulses, and it is well known that binary 1 represents the logic high and 0 represents the logic low. Now, there are several types of serial communication, depending on the type of transmission mode and data transfer. The transmission modes are classified as simplex, half duplex and full duplex. Let's become shortly familiar with transmission modes. Start with simplex method. In simplex method, either of the medium, that is, sender or receiver, can be active at a time. So if the sender is transmitting the data, then receiver can only accept and vice versa. So simplex method is one-way communication technique. The well-known examples of simplex method are television and radio. Second transmission mode is half duplex method. In half duplex method, both sender and receiver can be active, but not at the same time. So if the sender is transmitting, then receiver can accept but cannot send. And similarly vice versa. The well-known examples of the half duplex is the internet, where the user sends a request for a data and the gets it from server. And last transmission mode is full duplex method. In full duplex method, both receiver and transmitter can send data to each other at the same time. The well-known example is mobile phone. Apart from this, let's we discuss appropriate data transmission. The clock plays important role and it is one of the primary source. Malfunction of the clock results in unexpected data transmission, even sometimes data loss. So, the clock synchronization becomes very important when using serial communication. Most importantly, the clock is different for serial devices, and it is classified into type: synchronous serial interface and asynchronous serial interface. Now we discuss serial interface based on clock. First one is synchronous serial interface. It is a point-to-point connection from a master to a slave. In this type of interface, all the devices use single CPU bus to share data and clock. The data transmission becomes faster with same bus to share clock and data. Also, there is no mismatch in baud rate in this interface. The well-known examples are I2C and SPI. Second is asynchronous serial interface. In asynchronous serial interface, the external clock signal is absent. The asynchronous serial interfaces can be seen mostly in long-distance applications and are a perfect fit for the stable communication. The well-known examples are RS-232, RS-422, and RS-485.